Dear friends, welcome back to the channel. Today we'll be diving into another fantastic machine on the VulnHub, which is brainpan. The link will be put in the description section below so that you can download it and play it on your own. If you want to practice Buffer Overflow, I think this is right for you. And we need to, use various tools to make like debugger, reverse engineering. However, before we get started, make sure to subscribe to my channel and give this video a thumbs up. It really helps the channel grow. So now let's head over to Canics VM. First of all, we need to discover the IP address of the target machine. The utility I'd like to use, as always, would be net discover. So as you can see over here, the IP address of the target machine could be recognized. Oh, here besides the host machine and the internal DHCP server, we found two other machines. One of them belongs to Windows virtual machine. Maybe we can check its IP address. So I think 55. So let's go back, because afterwards I'm going to use Immunity Debugger, which is running on this virtual machine to to make debugging against some kinds of binary. Next, we can go back to the Windows VM. The IP address is this one, and victim VM is okay, and Canics is 2.3. So what shall we do next? We need to perform port and safe scanning with a map. To save the time of this video, I've already completed before. So now we can get out its result. Let's scroll up a bit. So as usual, the IP address of I took the options like scene scan, the virtual scan, the default script scan, and then full range port scan. The last option for all is ON to output the result into this file. Sorry, I need to confirm the IP address. Oh yes, 55. Oh, this should be 55. And the IP address of victim or target machine is 54. I'm a bit confused. So now let's go back to this terminal window. From the map scanning results, we can tell that the target machine has two open ports. The first one is for 9s, and the map can't determine its surface. And we need to enter the password. And the second open port is 10,000. The surface is HTTP. And it's running Python, simple HTTP server. So what are we going to do next? I think we can connect to this port number with netcat. Let's press enter. So welcome to brainpan. Enter the password. Hello. Of course, the password is incorrect. So we got access denied. So I think we can't do very much at this point for this port number. Let's move forward. The second port number, which is running HTTP service. So now we can fire up the browser to perform manual emulation first. port number 10,000. Press enter. So are you practicing safe coding, blah, blah, blah. And also we can check its source code. And we are given this address. If you want, you can take a look at this address. Okay, and now we can check to see whether this site has robots file or not. Error response. Next, we can launch Ligato to perform automatic immersion. So the target machine is running Python, simple HTTP. Although this is a bit outdated, I don't think we can manipulate or exploit this surface. However, we find this bin directory. Let's access this directory, and we find one Windows executable we can download to the Canics, and then we can move from downloads directory to current working directory. And we can use the file command to display its file information. So brain. So this is the 32 executable for Microsoft Windows. If you want, we can get back readable characters from this executable brain. Okay, a lot of output. Let's scroll up to see what we can get from this binary. So bind, initializing, WinSock, failed, couldn't create a socket, blah, blah, blah. And so size off. Some dynamic link library. Okay, I don't think we can do very much at this point. So what can we do next? And next, I'd like to launch GoBuster to perform directory immersion. I think following methodology is key to success of pen testing, right? So before we try to exploit this binary, oh, sorry, I forgot to specify the port number, which is 10,000. So this is the reason why we get this error. So now GoBuster starts its directory immersion. So without doubt, GoBuster also can find this bin directory. Again, I don't think GoBuster can find anything else. To save the time of this video, I'd like to stop it. Okay. So what can we do next? I think we can the only vector, which lies in this target machine. Oh, sorry. The only possible vector lies in the executable, and we need to observe behavior when we interact with this binary or executable. So how to do? I think in this case we need to introduce one of important debugger, Immunity Debugger, and I think I've already opened this link. Not this one. Yeah, this one. Immunity Debugger. And you can go to releases and download installer. The installation itself is very simple. I'm not going to repeat this process. I've already installed it. Also, we need to install, one of two or Python script, Mona. This can give us more functionalities, like, for example, can list modules which can be exploitable, okay? And also, for example, can find or search some strings. Okay, let's go back to the Canics. So how to next? Next, I think we need to transfer because I'm going to use Immunity Debugger, and the Immunity Debugger can only be running in Windows. So next I'm going to transfer this brainpan executable to Windows machine. And to save the time of this video, I've already done that in advance. So now let's go to the Windows. So I think, yeah, here I have already put this executable on the desktop. Okay, so what can we do next? I think we can, we can run as administrator. So next, let me go back to the terminal window. Next, we can connect to the Windows on this same port number. As you can see, we get the same, the banner, and we can put anything. Of course, access denied. So next, we need to, for example, how about we put a long string to see what happened, but nothing happened. We need to check to see whether this executable is vulnerable to buffer overflow. So how to do? We can utilize Python to automate this process. Okay, so how to do? I've already opened up the editor of PyCharm, and we can, this would be very easy. This would be very simple script of Python. We can import socket. This is built-in a module of Python. And also I'm going to import a time variable, module. And also I'm going to import sys module. This module can control the flow of our program. And we can have while loop, while true. Okay, and we can use the try and except constructor. But for now, I just put except and pass. So now we can initialize the instance of socket class. So socket address family IPv4, and I'm going to use TCP, so sock stream. And the next we can connect to the target machine on the port number 999. Here we need to pass a tuple. The first one is IP address of the target machine. Okay, and I'd like to define the variable size 100. So the payload is size multiply A. You always use the capital A to to test a buffer overflow vulnerability. Okay, and I'm going to use Python 3, so I think maybe we can use this way, the byte. This would be better. And next we can send this payload to the target machine. Okay, send and payload. Oh, sorry. So the payload, and we can close this socket. This socket, and we can introduce sleep or delay between every try. Okay, for example, like 2 seconds. And also I'm going to print some message. Try to send payload in brace. This is the formatted string, so the size bytes payload. Okay, and then we can size 100. If there is any exception, it means maybe the target machine has something wrong. So now we can print something wrong happen. at the target machine, okay? And at the when send payload in how many bytes. So the size. Now we can exit from the program. So that's it. Very simple Python script. So now let's go to, it's running. Now we can run this script exploit. Let's press enter. So try to send the payload in 100 bytes, then 200 bytes, then 300 bytes, 400, and so on and so forth. So 700 bytes, something wrong happened at the target machine when sent payload in 700 bytes. But next we need to know where exactly this kind of buffer overflow happens. And in this case, we need to use Immunity Debugger, okay? And however, before we start up Immunity Debugger, we need to create, the payload with particular pattern, okay? So we can use msfvenom pattern create, and the length, for example, like 200. So now we got this payload with particular pattern, and so if somewhere got error, and then we can use another utility to check its offset. Okay, so we can maybe we need to. I think we need to modify this code because we are not going to use while loop anymore. And okay, size, no need. So I think the payload would be here. Okay. That's it. And we do not need to use time and sys module. Now, let's bring back the terminal window and launch Python, followed by the file name or script name. But before we hit enter, we need to launch Immunity Debugger. Immunity Debugger works like a proxy, works between the CPU and our program. So then this can give us ability to observe as anything, right? So now we can open, this executable. So at the bottom, you can see this now. Currently, the state is paused, and now we can click run. Now the state is running. Let's switch back to Canics. So now we can press enter. So as you can see now, the EIP, in the Immunity Debugger, the 4 windows, the first one is the assembly window, and this one is register, for example, like EIP, ESP. The most important register are EIP and ESP. EIP means extended instruction pointer, which stores the address of the next instruction. Afterwards, we need to put the address of our shellcode, okay? And this window is the memory, and this one is the stack, okay? So now we have already got this address. We can copy selection, and maybe I can use the text. So Next, I'm going to query the offset. Let's go back to Canics. I'm going to use the pattern and offset Q option. Press enter. So exact match at this offset. So maybe we can copy. Next, I'm going to confirm our discovery. So how to do? I think I can delete the current payload because I'm going to, the payload should be uppercase A, offset is 504, and we can put uppercase P in the EIP, and this should be 4 bytes, and then we can put some C afterwards, like for example, like 775. It doesn't matter. So now we can save, and before we hit enter, we need to open this executable again. So now again the state is paused. We can click run, and then we can run it. Let's go to Windows machine. So here, as you can see, the EIP is 42. 42 stands for uppercase B. If you don't know about it, we can use XK. Oh, it's not installed. Anyway, so I think the 42 in the hex stands for the B, 4 multiply 16, okay, and a plus 2. This is uppercase B. So now, as you can see, the EIP has been overwritten or overflowed by our B. So what do we have to do next? We need to know how big payload we can put. So now let's go back to, sometimes, usually payload, the shellcode would be a bit big, like about 400 bytes or even bigger. So we need to know whether we can have space to put more or enough payload. So I just modify this to 500, and we need to restart this executable again, run it. So let's run it again. So as you can see over here, so ESP is 41 and 42. So now we can follow the ESP. We can follow or not. So here, so not, yeah, ESP. We can follow in stack. Okay, so this is the first address. We can copy this address, copy, and put over here. And we can scroll down all the way around here, and we can get this address. We can copy it again. We can copy it to clipboard. And we need to know how big space between these two addresses. So how to calculate? We can use Python 3. So we can copy this address and minus to this one. Oh, not this one. What I'm doing, I wanted to copy this address. Okay, 468 bytes. So I think this space is enough to put our shellcode to, to put our shellcode into the ESP. So now we can exit from Python. So next, what we have to do next, we need to find bad characters. Usually, not usually, in all cases, this 0 is bad character. This means intercept. And of course, we should exclude bad characters. However, different program will have different bad characters. Our job is to find other bad characters. To do that, we can, send more. We can send the payload with bad characters. And I think I've already, not this one. Yeah, the bad characters. Yeah, this one. You can clone and you can run it. So I've already done that before. So how to do? We can bad characters, run it, and we can copy these bad characters. Again, because I'm using Python 3, maybe Python 2 is a bit simpler when you construct a payload, but I think I suggest you use Python 3 also because Python 2 is outdated after all. Okay, so we can put here bad characters. Okay, and we can use this one. So this case is bad characters. We can save our program, and we need to reopen this executable one more time, run it, and then we can send this new payload. This new payload contains bad characters. Okay. Run it. So now, and we just needed to pay attention to ESP so we can follow in dump. So 10102. If any character disappear, and then we think that should be bad character. But if you check all the way here, everything appears in the dump. So it means that there isn't any bad character in this program except the 0. So next, what can we do next? We need to find the address of the next instruction. Okay, we need to put this address into the EIP. Now it's 42. This doesn't have any meaning. Will not do anything. Just throw out the error. This is not what we want. We want to execute shellcode, and our job is to find the address of the next instruction, and usually, shellcode would be near to ESP, and but ESP is dynamic. We need to find this dynamic address. So how to do? One common way is to find the the module which contains or which executes the jump ESP. Okay, let me go to the Canics, show you how to do in action. So we can use msfvenom and press enter. And JSP, ESP, or just lowercase, I don't know. Not JSP, jump, ESP. You know, this is a very common assembly operation, but we cannot directly use this, you know, assembly statement or instruction. We need to use operation code. Yeah, this one we can copy and put over here. So now let's go back to this one. We need to find the module which is vulnerable, and this module should execute the jump ESP. Okay, so how to do? And to find such a module, you need to install, you know, this script, the mola. I think I will also put the link in the description as well. Okay, and you need to put this Python script in this folder. Yeah, in this py commands folder. That's all. Okay. So now, what can we do next? And we can search. We can search mola. Oh, sorry. Mola and modules. And this command will list all modules. And for us, we need to find, yeah, here below this line, this is all modules which we can exploit, but we need to find, or we need to locate those specific module which is vulnerable, and set the security feature as disabled or false. Yeah, this one. This case just the executable itself. Some case we need to utilize some, you know, dynamic link library. Okay, but in this case we can use the binary itself, false. So next we can use another command to find the address of the jump ESP. Okay, so we can use find s means string x. So I cannot remember, ffE4 f x E4, and the module name is brainpan. Press enter. Indeed, we got the, you know, found a total of 1 pointers. So we can copy this address. We can copy this address because this address should be put into EIP register, and this will be pointed to, you know, the shellcode. The shellcode will be near to ESP. Okay, so now we can copy and put over here, or we can directly put over here. So next, what can we do next? We need to create the shellcode, and this is very easy. We can use the msfvenom and Windows. So, you know, maybe I will, you know, autocomplete this command. So this is the payload, and we need to specify the local host and local port number. And here I specify the bad character because just based on our, you know, check. In this case, this program has only one bad character, 0, 0. And also I use the encoder, and because this encoder is excellent encoder, can obfuscate our, you know, our code, and can bypass like a firewall. Okay, and you know, because msfvenom can support a lot of encoders and also the payload, I think if you have already followed my channel, I have already shown you how to get the payload what you want. In this video, I'm going to show you how to find the appropriate encoder. Okay, so we can use this one, msfvenom, and list encoder. So this command will give you all supported encoder. After all, we cannot remember everything, right? So in this case, this one is excellent. So we'll do some like XOR operation. We can copy. Of course, I've already done that earlier. Yeah, this one. So this case, I will use the port number 443. You know, 443 is safer in comparison to other port number because the target machine is Windows. So now we can press Enter. Okay, it's done. Now we can copy all of the code and we can go to the, I think we can remove the bad characters, right? And shellcode. And I think we can use princess. But I think it would be better to use the byte. If we're using Python 2, this is not necessary. But again, I'm using Python 3. I didn't find a better way to do this. Sorry about that. And so that's all. And next we need to put the EIP address. So here should be shellcode. Shellcode. So the Windows, yes, 52. So of course this address should be need to indent, or we need to reverse this address. We can copy and put over here. So we can use X F3, X F12, X17, X31. Okay. So I need to make double check X F3, F. Oh, this one should. So I think I need to remove this F, 12, 17, 31, shellcode. Okay, we can save. That's all. Next, I'm going to set up the listener on the Canics, waiting for collection from the target machine. Okay, so now we can restart, reopen this executable, run it. If we do not have any error, we can get the reversed shell from the target machine. Okay, so we can run Python 3 exploit. Let's press enter, but it's not working. So the IP address, shellcode. Why it's not working? So the payload I need to remove 31, 17, 17, 12, 17, 31. I can remove it. And so this code is correct. msfvenom. So the Windows, maybe I need to auto-complete this command to generate the code again. I don't know why I can't get reverse shell from the target machine. So why? I think Windows. So maybe we can copy it again. Okay, and we can put I need to make that when I need to make troubleshooting. It should work. Please be patient with me. Okay, I think it's correct now. Let me run it one more time, but open, run it, and we can run it, but it's not working. Sorry, I need to find out the issue. All right, as you can see over here, I successfully got back the collection from the Windows machine. So what I did just now, I need to put the non-operation, or select will not do anything. But sometimes this is unnecessary. For example, you can put 16 or 15. You need to try. So this is the reason why I failed, earlier. Okay. So anyway, now we successfully exploited the Windows machine. Next, we need to, revert to the victim machine or Linux. So how to do? We just make some small changes. Okay. So for example, we need to change the payload to Linux. After all, the target machine is Linux. Let's press enter. Okay, it's done. Now we can copy and put between parentheses. And as before, I think we can use byte for each line. And this case, IP address of the target machine should be changed to 54. And I think that's it. So now we can set up listener one more time, waiting for collection from the victim machine. We can run it. As you can see, we got back the collection. Beautiful. And next we can spawn an interactive shell by Python. Python 2 import pty spawn. Okay, so next we can, I think, of course, what are we going to next? We need to find vector, or we need to gather information to elevate privilege. For example, we can run sudo. We can run this command without password of root user. So we can run sudo. And we are given its usage. We can run command. Beautiful. We can copy And for example, we can run command who am I? Who am I? And then, you know, like Vim editor, we can use Vim editor to elevate the privilege, so we can run bin bash. As you can see, we have already become root user. And then, you know, I think that's pretty much it. I'd like to see you next. Bye. Have a nice day, please.